Today we're reviewing what we ended last year with, the ways to prove that triangles are congruent. So we're going to be reviewing all of those postulates that had all those letters as the abbreviations for different things. What are the things that we use when we are doing our proofs? So let's get started with getting some vocabulary written down. We're going to be proving that triangles are congruent, and in order for figures to be congruent, all of the angles are congruent, or all of the corresponding sets of angles are congruent sets, and all of the corresponding sides are congruent. For triangles, that means 3 sets of congruent angles and 3 sets of congruent sides. But we did not do proofs last year where we had to show all 6 of those congruencies. We had abbreviations, shortcuts where we had to show 3 or 4 things, and that was enough to then say that the triangles were congruent. We used several postulates, and postulates are simply things that we accept without proof. And one of the things that we used quite a bit last year, and we've already talked about on some of our problems this year, was AA implies AAA. That does not mean if you have 2 congruent angles, then the third angle is congruent. These are pairs of angles. If you have 2 pairs of angles, so you take 2 sets of the corresponding angles and they are congruent. You are also talking about not in a triangle, but in 2 triangles. So you have to have 2 triangles, 1 set of corresponding angles congruent, second set of corresponding angles congruent, therefore third set is also congruent. As you finish writing those down, try to start running through your head what were some of those different combinations of letters that we had last spring that were ways we could prove triangles are congruent. So let people be getting that written down. And then we'll start seeing which ones you can remember. And then we'll put all of that in our formula list for reference. Keith, do you remember one of them? Was your hand up just then? SAS is one of them. Does anybody remember another one? Matthew? HL. And does every triangle have a hypotenuse? So what kind of triangles are you talking about when you use that? What kind of triangles have a hypotenuse? So when you use HL, you're really doing right HL. You've got to have right triangle in the proof first and then HL. So we said SAS and HL. Callum, you remember a different one? SSS, so all of the sides, and then there was one more, and this one has 4 things in it, Shane. AAAS. So let's get our pictures down of how that works and refresh our memories. So SSS says you have 2 triangles, and you know that you have 1 set of corresponding sides, another set of corresponding sides, and the third set of corresponding sides is also congruent. That's enough to say the triangle is congruent. You do not have to go through and show angles are congruent, second set of angles congruent, second set of angles are congruent. That is enough. We abbreviate that with SSS as our reason when we are doing a proof. Another one that you mentioned was SAS, and for this one, the order matters. The angle must be between the sides. So that is saying, you know, 1 set of corresponding sides is congruent. You know, a second set of corresponding sides is congruent. The angle that you know, the angles that you know are congruent cannot be out here. because that would not be between these two sides. The angle that you have must be in between. It must be the angle that if you only drew your known congruent sides, they would draw the angle that you're talking about. And then we abbreviate that SAS in our proofs. You also recalled AAAS, which means you know that you have one set of congruent angles. You know you have a second set of congruent angles, or somehow or another you prove that from your picture. Usually you then use AA implies AAA to get the third set of angles. And then you know any one set of sides is also congruent. And then the reason that we put in our proof is AAAS. The final triangle congruency postulate is indeed HL, which really means three things. It means your proof has to say right triangles and congruent hypotenuses and a congruent leg. Not just two, even though we only use two letters for it. So we must have the right angle. We must know the sides across from that right angle are congruent, and one set of the two sets of legs. That's enough to say everything else is congruent and the triangles are congruent. The next slide will have some of the other things that we used in proofs to be able to say certain parts were congruent. So these were for complete triangles being congruent. The next set of slides will be talking about congruent parts and different ways that we can get there. Does anybody need me to wait? One is a right triangle. Two, you've got to have congruent hypotenuses and then congruent legs. But a lot of times we get confused and think just saying we've got two sides is enough for the proof. The proof must actually say right triangles. So if we're saying different parts are congruent, whether it's angles or sides, we've talked about something is equal to itself or congruent to itself. We talked about that in one of the homework ones a minute ago. What was the reason for that? Reflexive. We also have one that if we know this side is congruent to this side and the second side is congruent to a third side, then the first and third have to be congruent. Or one angle is congruent to another one, that angle is congruent to a third one, so the first and the third angles have to be congruent. Does anybody remember the name of that one? That one is called the transitive property, and it works for either equality or congruence. Same thing with reflexive property. And then the third one is that we can switch the order around. If we know A is the same as B, that means B is the same as A. Does anybody know the name of that property? That one you've kind of seen when you've had a line of symmetry through a figure. You can flip it back and forth and it looks the same if you flip it over that line of symmetry. So this one is called the symmetric property. So we have the reflexive property of equality, we have the reflexive property of congruency. Can use them either way around. And then there was one last big jumble of alphabet soup. Does anybody think you remember what all of these C's and T's and P's stand for? It's a little bit easy to get that mixed up. Ian. Perfect. It does indeed mean corresponding parts of congruent triangles are congruent. A lot of times we want to start off with congruent, but that first one is corresponding. The others are congruent. It would not really say anything if we said Congruent parts of something or other are congruent. Congruent parts are congruent. Well, of course they are. That doesn't tell you anything. Corresponding parts tells you something new. If you know these are corresponding, then you know they're congruent. If you are going to use CPCTC in your proof, you must go through your proof and you must have one line that says congruent triangles before you can use CPCTC. You must say that the triangles are congruent because you have to have corresponding parts of congruent triangles. So if you don't have congruent triangles, you can't talk about the corresponding parts being congruent. So you must have that as a line in your proof before CPCTC. Okay. To which one? 44 for just a moment. Transitive. Thing 1's the same as thing 2. Thing 2 is the same as thing 3. So thing 1 and thing 3 are the same. I feel a bit like Dr. Seuss. Are you okay to go on then? Okay, the next ones we're just going to figure out, are the triangles congruent and for which reason? We're not going to do the proof. We'll only do one proof on the last slide today. So, state the congruency postulate that could be used to show that the following pairs of triangles are congruent. So, we'd copy this down so that we can actually mark congruent things on our papers, since we don't mark that in the book. And then we'd start to label TV, so T to V, that's right here. That is congruent to W to V, so right here. And I also know U to V, so that's this one up here, is congruent to X to V, so this piece here. And now I'd like to be able to say that those triangles are congruent. Can anybody help me figure out what reason I would use for that? Blake? Okay, so we'd be able to say these are our vertical angles, and you did a beautiful job naming those with 3 letters, and you did it in the corresponding order. So we know that those are congruent because they are vertical angles. And then what else? So we would be able to use side, angle, side for that one. This is not reflexive. Reflexive says angle V is congruent to angle V in exactly the same place, just one angle. These are 2 different angles, which Blake did a great job of naming with the different letters to tell them apart. On ones like this, I want you to give the reason and write the congruency statement. So let's practice getting those in matching order. And so we pick one of the triangles, we write its vertices down in any order. So TVU is going to be congruent to the other triangle. And so let's see, I've already figured out that the V's match up, so I know V has to be the middle letter in there. And so let's see, T to V, is that going to be X to V? No, they're marked differently. T to V is the same as W to V, so that's a corresponding side. And then that leaves X over here. V to U corresponds to V to X. Questions with that? Next one. So once again, we'd write it down someplace where we could start to mark things on it. This time they tell us angle H is congruent to angle L. And then we know that HJ is congruent to JL. Am I going to be able to say that these are congruent? What am I going to think through with this one in order to get there? Help me out here. Do we know anything else on this one? Hope.
That angle IJH is congruent to angle KJL. Vertical angles.
Very good. That those are vertical angles. So then we can say these other ones. Angle, angle implies angle, angle, angle. So angle, 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 side, and we'll simply write our statement. So Hij on the left, and this is easy because we've already got the congruency marks on all of the angles. H is labeled the very same way as L. I is labeled the same way as K, and J and J. Questions for that one? Okay, last one of these short ones before the proof. So we want these triangles. Oh, this one's going to be easy. I see a right angle, so just HL, right? No, well, what did I just do wrong? Why can't I do that? Well, it's got a right angle. What else could it possibly be? You're exactly right. But I wanted to model that because I do see this a lot of times. Let's see. Maybe it'll end up being HL. Let's look at what we're told. We are told right triangles, HI and JK, so we do know this side and this side. IJ and KL, so we know this pair of sides. So I do know right triangles. Do I know the hypotenuses match? So therefore, I cannot use hypotenuse leg. So what will I use on this? Caleb? I will use SAS because right triangles or right angles are also congruent angles. So those angles are congruent. So I would say triangle HIJ is congruent to triangle, and I'm going to put K in the middle. H to I is labeled the same as J to K, and I to J is the same as I to L. So we're ready to do a complete proof. Okay, so here is our picture, and let's see. I can get a little bit more room to put that. I think you guys can probably still see that okay. And let me bring this up a little bit higher. So when you are doing proofs in my class, sketch is required. So yes, it's small to fit it in the box on your problem set, but draw a little sketch so you can label things as you put them in your proof, whether they're givens or things that you figure out. So we are going to start off with AB is congruent to CB. That is given. And I will label those on my picture. Then I am also given that angle ABD is congruent to angle CBD. So I can label that ABD is this one up here, and CBD is on this side. And then we're going to look at what are we trying to prove? Wait a minute, I'm not proving congruent triangles? How am I going to get to sides that match up? What am I going to end up having to use to get to matching sides? Maggie. So I'm going to have to get to CPCTC, so I'm going to have congruent triangles, then CPCTC. So how do I get congruent triangles out of this? I don't have any vertical angles like on some of those other examples that we were looking at. What are we going to do about this, Evan? Okay, we're going to use the reflexive property for side BD. That BD is congruent to itself. And you may use the tick marks if you wish. I usually just put a circle on top of something that I'm using the reflexive property on. That way I'm not hunting in my picture. What is it that matched up with this again? I know that just tells me it's going to match itself and I don't have to look for another symbol for that. Is that enough to have congruent triangles, or do I need still more? So Sharon, how could I say that those triangles are congruent? So perfect. Side angle side, and you did a perfect job of naming those the vertices in corresponding order. So I'm not sure I remember exactly how you said it, but triangle ABD on the left, Let me get back to the picture. C, B, D on the right would match up with that. We always write these in corresponding order. Then we look at what we're trying to prove. We want AD, so that's the first and the last letter, the way I happen to write this. So AD would be a side that corresponds to first and last letter over here in the second triangle, CD, so they would have to be congruent. So I can say, therefore, those two sides are congruent because corresponding parts of congruent triangles are congruent. Maggie? You don't have to. It's kind of nice to. When I was your age and doing these, I was required to, so it's kind of an old habit for me. But I'm not going to count off whether you do or you don't. Any other questions? Then good job on that today. We're going to use the rest of the time to be working on our homework today.